As usual, this latest version of IntelliJ IDEA contains improvements to the debugger. We've added class-level watches, which means that instead of a watch expression like this, which is visible at all times, you can add a watch so it applies to a specific class, which may be much more appropriate. As usual, these expressions can be any valid statement. The result will be evaluated and shown as a property of the class. To help make watches and variables even easier to see, IntelliJ IDEA 2016.3 has support for primitive type renderers. You could always use a Java type renderer to display objects in a friendly way. Now you can provide an expression to change the way primitives are rendered during debugging. This is probably most useful for displaying the contents of primitive arrays to see the values at a glance. As you've seen, type renderers are easy to add by right-clicking on a value and creating one from the View As menu. But you can also see and manage custom renderers either via Find Action or from the settings. Here you can add, remove, or edit the type renderers. Another new feature to help you see what's happening while you're debugging is the JVM Memory View. This is a plugin that you can add, which you can see I've already installed. You can find it by choosing to install a JetBrains plugin and looking for Memory View. With this plugin, when you're debugging something, you can open the Memory View window and see which classes are on the heap and how many instances there are. As you step through, the diff shows how many more instances are added to the heap. You can view the instances on the heap. Since we're looking at string, there are a lot of them. Often you'll want to look at classes from your own code. You can tell the plugin to track the creation of instances of a class. And now, when you step through, you'll see that you can click on the new instances. Here you'll see the details of the instance, and you can use the stack trace to locate where the object was created, in this case on line 22 of our test. You can even see the class-level watches and the values from our custom type renderers. This instances view could have a lot of values, as we saw earlier, so you can also add a filter to show only those that interest you. A useful debugging feature of IntelliJ IDEA is the ability to add exception breakpoints, which fire any time a specific exception is thrown. Here I've defined one for my custom exception class. In IntelliJ IDEA 2016.3, you can define class catch filters, which lets you narrow down when these exception breakpoints fire. For example, I can define a class to include, so if my custom exception is contained within a try-catch block in the UnderTest class, the breakpoint will fire. Here, we're running a test for the UnderTest class that will cause the exception to be thrown, and you can see the test correctly stops at the exception breakpoint. If we run a test that causes the custom exception to be thrown from within another class, the exception breakpoint does not fire. As well as include filters, you can define classes to exclude. We can define, for example, that we want to fire the exception breakpoint anytime except for when it's contained within a try-catch block in the ignore exception class. This gives us the same non-firing behavior for this test, but using excludes. Note that this filter behavior is all about defining the classes to include or exclude based on the try-catch block where the exception is caught. As well as defining includes or excludes based on specific classes, you can also declare a pattern for class names to include or exclude. Finally, now the debugger is smarter at figuring out which JRE is being used by the running application. This is useful if the project Java version is not the same as the running version. For example, this project is compiled against Java 1.8. If we run our tests with the default settings, when the debugger shows Java library code, for example ArrayList, we see the Java 8 version of the code. But we could be running the tests or our application against a different version, for example Java 1.7. If this is the case, IntelliJ IDEA 2016.3 recognizes this and shows us the Java 7 version of ArrayList. We can see that this ArrayList does not have the splitterator method, for example, and searching for 1.8 methods doesn't find anything. This ability to show code from the correct version makes debugging much more intuitive and useful in these situations.